Welcome to Aldiomis Prep Academy. The lesson for today is finding series using infinite limits.
Start off with example number 1. So in essence, sequences are lists of numbers that basically follow a specific pattern, and that pattern can be expressed as a formula or a function. And like one example of such a specific formula would be a sub n equals n over n squared times n plus 1. So in this formula, n basically represents the term number of the sequence. So a1 would be 1 over 1 squared times 1 plus 1, which is just 1 over 2, or 1 half. And then if we use this, we get the sequence a equals 1 half, 1 sixth, 1 12th, 1 20th, 1 30th, and so on. So from this sequence a, right, what we can do is we can create another sequence which contains what's called the partial sums of the first sequence. So what partial sums are they are basically denoted as s sub n, so that's how you write them, where n now represents how many terms starting from the first you're going to be adding together. That's why it's a partial sum, because you're adding part of it, the sequence, together. So s sub 1 is a1, which is 1 half, s sub 2 is a1 plus a2, which is 2/3, and s sub 3 is a1 plus a2 plus a3, which is 3/4, and this continues. So if we put these partial sums into a sequence and call it s sub n, now we get 1 half, 2/3, 3/4, 4/5, and so on. So what we can do is, basically, on the other hand, we have something called a series, where it's essentially the sum of the sequence. So rather than taking the sum of a few numbers at a time, we take the sum of the entire sequence. So if our sequence was 1 half plus 1 sixth plus 1 12th, so on, or 1 half, 1 sixth, 1 12th, then our series would be 1 half plus 1 sixth plus 1 12th, and so on. And you can see that the partial sums are part of this series. So taking the infinite limit of the sequence of partial sums tells you whether the series converges or diverges, because a series is essentially the last term in the sequence of partial sums. So as you can see, our partial sums have a formula for them, which is n over n plus 1. And if we take the infinite limit of this and we get a number, then the series converges to that number. But if we get plus or minus infinity, then the series diverges. So with our partial term sequence, s sub n equals 1 half, 2/3, 3/4, 4/5, 5/6, and so on, all the way to n over n plus 1, what we can essentially do is we take the limit to n as n approaches infinity of s sub n, which is the same thing as taking the limit of the pattern n to infinity of the pattern n over n plus 1. Now, if we directly plug in this limit, we get the indeterminate form, which means we now have to use L'Hopital's rule. So we basically take the derivative of the numerator and denominator, and that's going to give us 1 over 1, which simplifies to 1. So therefore, the series converges to 1.
Example number 2. Given the sequence a sub n is equal to 3 over n times n plus 1, find the infinite limit of the series s of n equals the sum from n equals 1 to infinity of a sub n. Now we can find the first few terms of the sequence to help us find the partial sums of the series. So a sub 1 would be equal to 3 over 1 plus 1, which is equal to 3 halves. A sub 2 would be 3 over 2 times 2 plus 1, which is equal to 3/6. A sub 3 would be 3 over 3 times 3 plus 1, which is equal to 3 over 12. And lastly, a sub 4 would be equal to 3 over 4 times 4 plus 1, which would be equal to 3 over 20. Now that we have the first few terms of the sequence, we can find the partial sums. So s sub 1 would be equal to 3 halves, s sub 2 would be equal to 3 halves plus 3/6, which is going to be equal to 6 over 3, S sub 3, which is equal to 3 halves plus 3 sixths plus 3 twelfths, which is going to add up to 9 fourths. And then S sub 4, which is 3 halves plus 3 sixths plus 3 twelfths plus 3 twentieths, which is equal to 12 over 5. Now, looking at the first few partial sums, we can identify the pattern to see that the nth partial sum is equal to 3n over n plus 1. So now we can take the limit to infinity of 3n over n plus 1, which would be taking the limit to infinity of 3n over n. We cancel out the n's, and the limit to infinity would be 3. Therefore, the infinite series from n equals 1 to infinity of 3 over n times n plus 1 converges to 3. Thanks for watching.